Okay, so I'm going to be going over the double label conversions and density worksheet that you had. I'm going to go through each problem and I'm going to work out the problem, and I would like you to stop the video before I start working that problem. Try to solve it yourself, and then if you get stuck you can play it, see where I correct you or see where I keep going in the steps so that you can do the correct answers. I'm going to put all the answers in the correct number of significant figures. And I'm going to try to write each of them in scientific notation so that way on your test you are able to do that as well. So this first problem, I have 1.3 times 10 to the second meters divided by minutes to centimeters divided by hours. Okay, so the first step you should do is write the number 1.3 times 10 to the second. Okay, so that's the first step. Now I'm going to need to change meters to centimeters, and then I'm going to need to change minutes to hours. Okay, so it doesn't matter which one you do first, it matters that you are consistent. So let's do meters divided by minutes. Okay, so that's my first number. 1.3 times 10 to the second meters divided by minutes. Let's do meters first since it's on top. I have meters, I need to change it to centimeters. So what we're going to do a one-step problem here. So if I have meters here, meters will go at the bottom so I can cancel them out. And then I need to change that to centimeters. In order to do that, which one's going to get the 1? It should always be the one with the prefix, the one with 2 letters here. So the one at the top should always get the 1. And down here, the centi is going to tell me what goes in this box. So it'll be 1 times 10. Centi is negative second power. So if I'm canceling out my units, I can cancel out meters right now. And now I have centimeters on top. Great. So check, I got that one done. Now it's time to convert minutes to hours. So we're gonna make another step here. And now we're gonna go minutes to hours. We're gonna start, minutes is at the bottom. I want to cancel that out, so I need to put minutes on top to cancel it out. Okay? And in this problem, we're converting it to hours. So hours. Now, how many minutes are in 1 hour? So we know that in 1 hour, there are 60 minutes. Looking here, I can cancel out minutes now. And now I have hours at the bottom. I want hours at the bottom, so I'm good. Now that I have both the units, centimeters and hours, all I have to do now is solve the problem. Let's take a minute and put in the calculator. Okay, and this is the answer I would get. So it would be 7, 8, 1, 2, 3, 4 centimeters divided by, because there's a line, centimeters divided by hours. There you go. But this isn't written in scientific notation, so we have to write it in scientific notation now. Remember, if there is no decimal in the number, it's always at the end. And we're going to move it over 1, 2, 3, 4, 5 times. So it should be 7.8, 2 sig figs, because that's what we started with up here, times 10 to the 5th power centimeters per hour. And there goes our first answer. Okay, pause the video and try to do number 2. So for number 2, we start with 15. That's the number we start with, 15. And in this problem, I'm going from kilometers to meters. Nope, sorry, it's focusing. Then I'm going to go from hours to seconds. So let's write our number, 15 kilometers. We're going to make our little chart. 15 kilometers divided by hours, because there's a line there, divided by hours. So we're going to put 15 kilometers divided by hours. Okay. Let's do the kilometers first. We need to change kilometers to meters. That's our first step. So kilometers is here. I need to cancel it out, so I'm going to put kilometers on the bottom. And I need to go to meters in this problem. The 1 will go with the prefix, the kilo. Kilo tells me what goes here. 1 times 10 to the 3rd power. Kilometers cancels out. Now I have meters on top, and I want meters on top over here, so we're done with meters. Okay. Now I need to change the bottom, and it needs to say seconds at some point. So right now it's at hours. Let's change it. So in order to get rid of hours, I have hours at the bottom. I'm going to put hours on top, like that. And now I want to go to seconds. Now, if you don't know what the number is, you don't know how many seconds are in an hour, that's okay. The first thing you should do is like, okay, I know how many minutes are in an hour, because we just did that up here. So let's do that. Let's convert to minutes first. So my hours will cancel out. There is, in 1 hour, there are 60 minutes. But I have minutes at the bottom. I wanted seconds, so I have to go one more step in order to go to seconds. Minutes goes on top, so I can cancel it out. Seconds goes on bottom. Minutes gets canceled out. In 1 minute, there are 60 seconds. Now, do I have seconds at the bottom? Yes. So then we're done. All we need to do now is plug it in the calculator correctly. So plugging it into the calculator, I'll do it with you. You should have gotten, in 2 sig figs, because that's what we started with, you should have gotten 4.2. It'll be meters per second. But I want it in scientific notation. So since I don't have to move the decimal because I only have one number on the left side, we're going to say this is 4.2 times 10 to the 0 power meters per second. This would be the correct answer right here. Okay. Next one. Let's write our number first. That's always the first step. Let's try doing that. Okay, that's better. 1 point, what was it? Oh, 9, just kidding. Times 10 to the negative 5th power. I have nanometers. Here we go. Nanometers to kilometers. And then I have minutes to seconds. So 1.9 times 10 to the negative 5th nanometers. Divided by minutes. That's what it says here. Nanometers divided by minutes. Nanometers divided by minutes. Okay, let's keep going with the meters. We're going to convert meters first. Now, the rule about this one is that in order for us to go from nanometers to kilometers, we have to go to the base first. You can't just go from prefix to prefix. You have to go to a meter first. So in order to do that, we'll have nanometers here. We're going to put nanometers at the bottom. We're going to meters first. Now that I'm in meters, now I can go to kilometers because I'm going from a base to a prefix. So this would be meters to cancel it out, and I want to have kilometers on top. Okay. All right, so looking at just these two, the 1 goes at the bottom because this is the prefix. Meters on top is 1 times 10 to the negative 9th power. Over here, the 1 goes with the prefix. Kilo tells me what goes here, 1 times 10 to the 3rd power. Cancel out my units, nanometers, meters. Now I have kilometers. I wanted kilometers, so we're good. Now I need to change this minutes to seconds. Okay? So in order to do that, let's add another step. Minutes is here. I need to cancel it out, so I'm going to add it at the top. Minutes, seconds. In 1 minute, there are 60 seconds. Minutes will cancel out. I'm left with seconds. Boom, we're done. We have the 2 units we want. I have kilometers there, seconds there. So now all we need to do is plug it into the calculator. And in your calculator, you should be getting... Wait, did I get that? Oh yeah, I did. Okay. I'm sorry. And 2 sig figs, because that's what we started with, is 3.2 times 10 to the negative 19th power. And it is kilometers divided by seconds. So kilometers divided by seconds. It is already in scientific notation, so that would be our final answer. Yay. I'll just move it at whatever, next 2. Next 2. So I have here, a driver can cover 4,004.3 meters in 8 hours of driving time. What is the driver's rate of travel in kilometers per minute? So a lot of information here. First thing to do, I'm going to make this all one single color because this is a double label. So since this is a double label with 2 different numbers here, we're going to just write what we start with. 4,004.3 meters divided by in 8 hours, so it took us 8 hours. 8.00 hours. And so that's our first 2 numbers. So he went this far in that many hours, and they want to know how many kilometers per minute. Oh wait, just kidding. I'm gonna color code it. Let's just pretend I wrote that in blue and I wrote this in green. So, so I need to change meters to kilometers, and I need to change hours to minutes. So let's do the first part, meters to kilometers. I have meters here, so let's put meters at the bottom. Let me extend this line a little bit. There we go. And I'm going to kilometers. KM. The 1 goes with the prefix kilo. Oh, sorry, you can't see. Kilo tells me what goes there. So 1 times 10 to the 3rd. I'm sorry, that is a 3, just a normal 3. There it is. That probably looks better. Probably not. Great. And then my meters cancels out. So I'm just left with kilometers. Great. That's what I want. Now, in order to do the next one, I need to change hours to minutes. Hours is at the bottom, so I need to put it at the top to get rid of it. Minutes goes on the bottom. In 1 hour, there are 60 minutes. So hours cancels out. Now I have kilometers per minute. Now I have minute at the bottom. Yay. Now we just plug it in the calculator. 4,004.3 times 1 divided by 8 divided by 1 times 10 to the third power divided by 60. Did I get that? I did. So you will get 0.00834 3 sig figs, because ours is in 3 sig figs. So this is my third sig fig, rounded correctly, and that'll be kilometers per minute. Now it's not in scientific notation, so we need to change it to scientific notation. 1, 2, 3. It's a small number, so 8.34 times 10 to the negative third power kilometers per minute. Bam. Alrighty. Alright, this one I'm going to do only in one color. In this problem, we have number 5. If the density of gasoline is 0.680 grams per milliliter, how large is the container in liters would you need to hold 7.20 kilograms of gasoline? So I want to figure out what liters is. Liters is a volume. Okay? Since liters is a volume, then that's the letter I'm going to be solving for. So what is the formula for density? It is density is equal to mass divided by volume. Okay? Mass divided by volume. Now to get volume, I have to first get it out of that denominator. There it is. Denominator. So the only way you can do that is if you take it out. So times volume on both sides. And so I'll get volume times the density equals the mass, because on this side they cancel out. Volume is still not by itself though, it is with density. So I need to divide by density on both sides. On the left side it'll cancel out. So my equation now is volume is equal to mass divided by density. Just like that. Now I'm able to plug it in. So my mass goes first, so 7.20 kilograms divided by density. You need to put density in its own column. Why? Because it has 2 units with it, grams and milliliters. So it needs to have its own little column here. So since I'm dividing by density, that 0.680 has to go at the bottom of the chart, down here, 0.680. You can put the 0 if you want, it doesn't matter. So 0.680 grams divided by, this line means divided by, this line means divided by, milliliters. Grams divided by milliliters. What unit can cancel out? None of them. This is kilogram, this is gram. So I can't cancel that out. This is milliliter, that's not even what they want. They want liters. So there's quite a few steps we need to take here. It doesn't matter which one you do first. I'm going to do the gram first. I want to get rid of kilogram and gram. I need to get rid of both. So in order to do that, I'm going to put kilogram on the bottom so I can cancel it out. And I'm going to put gram on top to cancel that one out. So the kilogram gets the 1. Kilo on our chart is 1 times 10 to the third power. And like I said, kilogram gets canceled out with this one. Gram gets canceled out with that one. Great. All we're left now with is milliliter. Now they want liters, so I have to do a step to get to that. So milliliter is here. Milliliter on bottom to get rid of it, and I'm going to liters. 1 milliliter, milli tells me what to put here. 1 times 10 to the negative third. Milliliter gets canceled out. The only unit that's left is liters. Then I'm done. Just plug it in now. So it'll be blah, 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 liters, because that's my final unit. So let's plug it in. Oh, rats. Oh, rats. Okay, hold on. Give me a second. Being a slacker. Let's say I was wrong the second time. Okay, so whatever. Sorry. The answer would be in 3 sig figs, because both of these are 3 sig figs. It would be 10.6. Now, is this in scientific notation? No. Correct. So we need to change it. We're just going to move it one time right there. 1.06 times 10 to the first power liters. Sorry. And there you go. Okay, a few more. These are more difficult. Number 6. Number 6. It says the box has a density of 4.6 grams per centimeters cubed. What is the mass of the box? So before I keep reading, I already know the formula I'm going to use. Density is equal to mass over volume. That's one of the equations. If the height, height, new word, is 24 centimeters, the width is 14 milliliters, and the length is 2 centimeters, so they give me that information. So in order to get mass, I need to know what the volume is and the density. So let's rearrange this equation so mass is by itself. I'm going to multiply times volume on both sides. On this side, volume goes away. So the equation I should be using at the end is volume times density equals the mass. But in order to use that, I need to know what the volume is and the density. I know what the density is. They give it to me right there. But I don't know what the volume is. We have another equation for that. That is, where are you? There you are. That is volume is equal to the length times width times height. So in a cube, volume is equal to length times width times height. So here they give me a height, they give me a width, they give me a length. Let's plug them all in. They're all being multiplied, so they should all go in the chart. And yes, Isabella, you have to make the chart. Just like that. Length goes here, which is, in this problem, it is 2.0 centimeters. The width goes next, 14 milliliters. And last one but not least, the height, which is 24 centimeters. Now, volume itself, volume can only be a couple of units. I'm going to put it over here. Volume can only be in milliliters or centimeters cubed, or you can even put it in liters sometimes if they ask for it, like in those other problems we've done. But in this case, we need it in centimeters cubed. So I need 3 sets of centimeters here. I don't have, this one is not a set of centimeters, it is milliliters, so I need to change it. In order to change it, all you got to do is do a little one step with it. If I'm going from, where should I put this? Let's put it here. Milliliter to centimeter. Don't forget, prefix to prefix, you have to go to meter first. Okay? So, in order to go to do that, I have milliliter here, millimeter, going to meter. Now I can go to centimeters. Go from meter to centimeters. Meters is here, meter on bottom, going to centimeter. Out of these two, this one gets the 1 because it has a prefix. Milli tells me what goes here. 1 times 10 to the negative third power. Same thing here. 1 goes there. Centi tells me what goes here. 1 times 10 to the negative second power. Canceling out units. Milliliter, meter. Now I have 3 sets of centimeters. Now I can get a volume. So now we plug them all in. You should get, rounded to 2 sig figs, you should get 67 centimeters cubed. That's what you should get. Once you have that, now we have a volume. That's our volume. So now that I have a volume, I know the density from up here. Now I can plug it into this equation. Okay? So plugging it into that equation, now I have volume times density. Volume will go on top, so 67 centimeters cubed, times density, so the number goes on top, 4.6 grams divided by centimeters cubed, grams divided by centimeters cubed. I have centimeters cubed on top and bottom, so they get canceled out. So I'm left with grams. If I plug it in and round correctly, I'll get 310. 2 sig figs because my density is in 2 and most of my, or all my length, width, and height are all in 2. And then we have to change it to scientific notation. There's the decimal, 1, 2, 3.1. Oh, that's it, because 2 sig figs. 3.1 times 10 to the second power grams. Oh, didn't box this in. There you go. Okay. Next one. Oh goodness. There it is. Okay, next one. Next one is a very simple problem. They want me to figure out what density is here. Density is equal to the mass divided by the volume. Right here is my volume. Right here is my mass. I just plug them in. But you still have to make the table. So mass is 15 grams. Divided by volume, so volume goes at the bottom. 24.0 milliliters. Do any of my units get canceled out? Of course not, because they are all different. So you will get, for your answer, rounded to how many sig figs? 2 sig figs would be 0.63 grams divided by milliliters. And since this is grams divided by milliliters, we're done. But you have to change it to scientific notation. So got to move it over 1 time. 6.3 times 10 to the negative 1 grams divided by milliliters. Done so. And the worst one, the last one. This one's awful. So in this one, a box has a density of here, boom, density. The box weighs that many grams, mass. What is the height of the box? So they want to know a height in this problem. If the width is this and the length is that. So if they want to know a height, then we're using this equation. Volume is equal to length times width times height. If they want to know the height, I need to get height by itself first. So I need to divide by the length times the width. Divide by the length times the width. Sorry, I ran out of room there. Whoops. On this side, it cancels out. So I'm left with height is equal to volume divided by length times width. So this is the formula I need to solve my answer. That's it. I need a volume, I need a length, I need a width. I have a length right there. I have a width right there. But I don't have a volume, so I need to solve for volume. In order to solve for volume, you need to use this equation. Density is equal to mass over volume. We've already done it before, where up here we rearranged the equation. If you don't remember, you can go to number 5 and see how I did that. So eventually I'm going to get to the point where volume is equal to mass over density. So we got to plug it in. The mass is 320 grams. Divided by density. Density gets its own column. 19.3 grams divided by centimeters cubed. Grams gets canceled out. So my final unit, when I put this in the calculator, will be in 2 sig figs, because 320 is in 2 sig figs, would be 17 centimeters cubed. And that is my volume. Okay. So I have a volume, I have a length, I have a width. Now I can plug everything into that one formula. So let's go. Volume here is, oh, I just did it, 17 centimeters cubed. Divided by the length, because length is at the bottom, so that number is going to go at the bottom. The length in this case is 440 milliliters. And last but not least, divided by the width. The width in this case is 0.020 kilometers. Now, no unit here cancels out. You know what, I'm probably even going to need an extra side of the paper because I'm definitely going to run out of room. Okay, no unit cancels out. Great. So that means what we have to do now is we have to convert everything. So in order to do that, I need everything to be in centimeters so I can cancel out 2 of those centimeters. My height needs to be in centimeters. So at the end I need everything, all 3 of these need to be in centimeters. So to do that, to go from millimeters to centimeters, remember, I have to go to meters first. You have to go to the base first. So, millimeters here, millimeters, meters on bottom. The 1 goes up here with the millimeters because it's a prefix. 1 times 10 to the negative 3rd power. Next, so millimeters cancels out. I still don't have centimeters though, so I need to take it another step. One more step. Meters goes here because I can cancel it out. Centimeters. Yay. Centimeters gets the 1. Centi is 1 times 10 to the negative 2. Meters cancels out. Now I got centimeters at the bottom. Good job. Now I need to get kilometers, and I need to change that to centimeters as well. In order to do that, prefix to prefix, we have to go to the base first. So, kilometers is at the bottom. I'm going to put kilometers on top. Meters on bottom. 1 times 10 to the 3rd power, because a kilo. And finally, I need to get, oh, I'm sorry, kilo now cancels out. Kilo there, kilo here. Now I'm at meters. I need to change it to centimeters. So I have meters here, meters, centimeters. 1 goes there, 1 times 10 to the negative 2nd power. Now don't stop just because it's too long. No, keep going until you get what you want. Meters cancels out. So if I look back now on this problem, I have centimeters cubed here. I have centimeters here. And I have centimeters here. There's 2 at the bottom, 3 at the top. So it's only going to leave me 1 left over. Great. That's what I wanted. That's what they wanted in the problem. They wanted centimeters over here. Great. So now all we got to do is plug all this in, and we will get our answer. I already solved it somewhere. You should get, it should already come in scientific notation in your calculator. In 2 sig figs, because this is in 2, this is in 2. It'll be 2.0 times 10 to the negative 6 power. And you are finally finished with this.